Today's discussion is about testing hypothesis using chi-square test. So as we discussed in the previous class, a chi-square test is a statistical test used for categorical data, and it used to determine whether our data are significantly different from what we have expected. So in order to test our hypothesis using a chi-square test, there are several steps are involved. So the first step is formulation of hypothesis. So every research starts with a hypothesis. Hypothesis can be either null hypothesis or alternative hypothesis. Null hypothesis says that there is no significant relationship between the categorical variables, whereas the alternative hypothesis says that there is a significant relationship between the variables. For example, if a researcher wants to evaluate whether there is a relationship between smoking habit and lung cancer, he can start his research with two hypotheses. That means the null hypothesis. So in this case, the null hypothesis is there is no significant difference between, or there is no relationship between smoking habit and lung cancer, whereas the alternative hypothesis in this case says that there is a relationship between smoking habit and lung cancer. So this is the example where the researcher having the data for 400 people. So among the 400, 200 are smokers and 200 are non-smokers. Among the smokers group, 70 develop lung cancer, whereas in the non-smoker group, 30 develop lung cancer. So this is the example. So as we discussed in the previous slide, the testing of hypothesis using chi-square test involves several steps, and the first step was the setting hypothesis. So in this case, the null hypothesis is there is no relationship between smoking and lung cancer, and the alternative hypothesis is there is a relationship between smoking and lung cancer. So that was the setting the hypothesis was the first step, and the second step is set the significant level. So the researcher can either set his research at 99% of confidence interval or 95 or 90% of confidence interval, and according to that confidence interval we have to select the we have to set the alpha value. We have to choose the alpha value. So in this case we select 95% of confidence interval. So the corresponding alpha value is 0.05. The third step is calculating the expected frequency. So expected frequency is nothing but it is the theoretical number of occurrence for each category or each cell, assuming that the null hypothesis is true. So it can be calculated using an equation, row total into column total divided by grand total. So for each cell, so that the table shows the expected frequency for each cell, that is the individuals, the people having lung cancer and not having lung cancer in the smoker group, as well as the people having lung cancer and not having lung cancer in the non-smoker group. So the expected frequency, it is nothing but the theoretical number of occurrences for each cell, and it is calculated using the equation row total into column total divided by grand total. And for the data what we have in the slide number 3, we calculated the expected frequency using this equation, and it is shown in this particular table. The fourth step is computing the chi-square statics. So the chi-square statics or chi-square value is equal to the sum of observed frequency minus expected frequency all square divided by expected frequency. So observed frequency are nothing but the value and the actual value what we got from what we got in our research, and that is shown in slide number 3, and the corresponding expected frequencies for each cell is shown in slide number 4. So the chi-square value, we will chi-square value, it is nothing but the sum of this observed frequency minus expected frequency all square divided by expected frequency for each cell. So in the first cell, that is smokers, and among the smokers there are 70 70 are having lung cancer. So the observed frequency is 70 and the corresponding expected frequency, it is shown in slide number 4, that is 50. And in the second column, that is smokers having no lung cancer, and the observed frequency is 130 and the corresponding expected frequency is 150. And next is the non-smoker group. In the non-smoker group, there are 30 smokers and the corresponding expected frequency is 50. And in the non-smoker group, the people not having lung cancer is 170 and the corresponding expected frequency is 150. So calculate the chi-square value using the equation observed frequency, sum of observed frequency minus expected frequency all square divided by expected frequency. So in this particular case, the chi-square value is 21.34. The fifth step is determining the degree of freedom. Degree of freedom can be calculated using the equation row minus 1 into column minus 1. In this particular example, there are 2 rows and 2 columns. That is, the rows are smokers and non-smokers and columns are lung cancer and no lung cancer. So 2 columns and 2 columns the data is having. So the particular data, the degree of freedom is 1. And the next step is compare the chi-square value with the critical value. Critical value means for each set of data having a particular alpha value and particular degree of freedom, there is a critical value, and the critical value can be directly get from the chi-square distribution table or can be calculated using suitable softwares. So in our case, we set the confidence interval at 95%. So the alpha value is 0.05 and the degree of freedom is 1. So for a set of data having alpha value of 0.05 and degree of freedom 1, the critical value is 3.84. So it can be get directly from the chi-square distribution table or it can be calculated using suitable statistical software. So in our case, the critical value is 3.84. That means at alpha value 0.05 and degree of freedom 1, the critical value is 3.84. So the final step is interpreting the result. That is, the test says that if the chi-square value, calculated chi-square value is greater than the critical value, then the researcher has to reject the null hypothesis. So this is the condition 1. In condition number 2, the chi-square value is less than the critical value. Then in this case, the researcher has to accept the null hypothesis. In this particular example, the chi-square value is greater than the critical value. So the researcher has to reject the null hypothesis. So the null hypothesis was there is no relation between smoking and lung cancer, and the alternative hypothesis was there is a relationship between smoking and lung cancer. So since in this particular case, in this particular example, the chi-square value is greater than the critical value, the researcher has to reject the null hypothesis and accept the alternative hypothesis. So that means the conclusion is that we have to accept the alternative hypothesis. Means in this example, it means there is a relationship between smoking and lung cancer. So these are the steps involved in testing hypothesis using chi-square test. So the first step was nothing but setting the hypothesis. So according to the research, the researcher has to set the null hypothesis as well as the alternative hypothesis. Then the researcher has to set the confidence interval. So in this particular example, the confidence interval was set at 95%. That means there is only 5% chance for an error come into this result, and the corresponding alpha value for this 95% confidence interval is 0.05. And the next step was to calculate the expected frequency. Expected frequencies are nothing but the theoretical number of occurrences for each cell. So it can be calculated by using the equation row total minus column total divided by grand total, and the expected frequencies for each observed value are shown in slide number 4. And next we have to calculate the chi-square static. So after setting hypothesis, the next step is selecting the alpha, set the alpha value, and then the third step was to calculate the expected frequency, and the fifth value was to calculate the fifth step was to calculate the chi-square statics. So the chi-square statics can be calculated using the equation chi-square statics chi-square value is equal to the sum of observed value minus expected frequency divided by expected frequency, and it is shown in slide number 5, and the observed frequencies are shown in slide number 3, expected frequencies are shown in slide number 4, and using this observed frequency and expected frequency we calculate the chi-square value, and the chi-square values calculation are shown in slide number 5. And next we'll determine the degree of freedom, and finally we'll compare the chi-square value with the expected value. So chi-square value with the critical value, and the critical values can be for a particular data having a particular alpha value and particular degree of freedom. The critical value can be directly obtained from the chi-square distribution table, or we can calculate using softwares by giving the alpha value and degree of freedom. In this particular case, the alpha value is 0.05 and the degree of freedom is 1. So a data having alpha value of 0.05 and degree of freedom 1, the critical value is 3.84. So now the final step is comparing the critical value with the chi-square value, and the test says that if the chi-square value is greater than the critical value, then the researcher has to reject the null hypothesis and accept the alternative hypothesis. And in case if the critical value is more than the chi-square value, then the researcher has to accept the null hypothesis and reject the alternative hypothesis. In this particular case, critical value is greater than the chi-square value is greater than the critical value, so we have to reject the null hypothesis and accept the alternative hypothesis. So this is about calculating or testing hypothesis using chi-square test.